Okay, show that that simplifies to ax where x is an integer. So it's a show that question, doesn't matter, all that means is just do the question and the answer will happen to be in the form ax, okay? So we just have to simplify that. So what have we got? Well, let's start here. 3x plus 6. All of that equals, we can take a factor of 3 out, leaving x plus 2, okay? Now, I bet that if we factorize this, one of the factors will be x plus 2. They always set up these questions so that these cancel after you've factorized. So, you know, I'm so confident of this, I'm even going to write x plus 2 straight away. And I bet you that that's one of the two factors of this quadratic. So plus 2 times what gives minus 10? It's definitely x because it's only x squared. 2 times minus 5. Now if we multiply that out, I bet you we get that. So let's see. Well, let's do it over here. So x times x is x squared. X times minus 5 is minus 5x. 2 times x is plus 2x. And plus 2 times minus 5 is minus 10. So that's x squared minus 5x plus 2x is minus 3x minus 10. Oh, what a surprise. I was right. Like I say, they always set these up so that these brackets cancel after you've factorized. Okay, let's turn that into a times and flip this. So if you've got a over b divided by c over d, then the standard fractional division, okay, that's equal to a over b times d over c. You turn it into a times and flip this one. So we've got this one on top now, where we can take out a factor of x. X goes into x squared minus 25. Okay, and we've still got just x plus 5. Good. So cancel, cancel. We're left with 3 over x minus 5. Don't need the brackets anymore. Times x. We can factorize this. This is a difference of 2 squares. You should get used to spotting difference of 2 squares factorizations, okay? Whenever you have something of the form x squared minus, and then this number is a perfect square, such as 4, 9, 16, 25, 36, 49. In this case, it's 25, it's 5 squared. Then you can immediately factorize that. It's very easy. It's just equal to x plus the square root of that number and x minus the square root of that number. Okay? So get used to spotting those. Like I say, x squared minus 4, x squared minus 9, x squared minus 16, and so on. I'll prove it to you. Why is that the case? Well, because you get this plus 5x minus 5x, they cancel out. So you don't get an x term, you just get an x squared and 25. So let's multiply this out. X times x is x squared. X times minus 5 is minus 5x. 5 times x is plus 5x. Plus 5 times minus 5 is minus 25. And as promised, minus 5x plus 5x cancel. So you're just left with x squared minus 25. And I just gobbed on the screen. Moving on. Okay, so that's x into x plus 5, x minus 5. And again, surprise, surprise, it's going to cancel with the x plus 5 on the bottom. Right, so let's do some cancelling. So x plus 5 on the top there, x plus 5 on the bottom. Ah, look at this. We have x minus 5 on the bottom and x minus 5 on the top. So what we're left with, just 3 times x, which is 3x. Done. You see, it does indeed simplify to ax where a is an integer and a is 3. There you go.